This video is part of the Rocketry Basics series. It explains how black powder model rocket engines work. It will explain concepts, terms, and definitions that everyone involved in rocketry needs to understand. This picture shows some typical black powder engines with their igniters. Notice they come in a variety of sizes. Estes or Estes is the brand name of the leading, but not the only manufacturer of black powder engines. Black powder is also known as gunpowder, and it is what is used in most fireworks. Composite engines are similar, but use a different kind of chemistry, in other words, a different fuel. Their internal design and igniters are similar, but slightly different. In this video, we're only going to talk about black powder engines. In a future video, we will talk about composite engines. This diagram depicts the internal construction of a typical black powder engine. The engine is built inside a casing. The casing in a black powder engine is simply a thick-walled, heavy-duty cardboard tube. Inside the tube, there are three types of black powder, with three different formulations that are specifically designed to burn at different rates. The first of those types is the fuel. It is the part of the engine that burns and produces the thrust. It's a very rapid burning black powder, produces a lot of gas and smoke and flames, and produces the thrust that generates the acceleration of the rocket. The second type of black powder is called a delay charge. This is a very different formulation. It is actually a slow burning fuel. It does not produce any flame. It produces a little bit of smoke, and it doesn't produce any thrust. So the delay charge is burning during the coasting phase of the rocket. And finally, there's the ejection charge, which is a very small amount of very, very fast burning fuel, black powder at the top end of the engine, which burns and goes off like a little firecracker that pressurizes the rocket to cause the ejection. It's usually referred to as the ejection charge. The other two parts of the engine that we need to understand are the nozzle. That's the back end. That's the part that steers the exhaust gases out the back end of the rocket when the fuel burns. It's made of a ceramic material. It's a clay that's been fired, so it does not burn up. It remains there even after the engine is completely gone. And the final part is the ejection charge capping. This is just a little bit of material that's put over the top of the ejection charge to keep the ejection charge from falling out before the engine is used. The only other part of the engine that we haven't shown in this diagram is the igniter. The igniter is a small device that's put into the back end of the engine. It comes in through the nozzle and goes into the fuel. It has two wires that come out of it. And what we do is we put an electric current through this. The igniter gets hot and it starts the fuel burning. Therefore, it's called the igniter because it's what's used to ignite the engine. This is a brief animation of how these engines work. We have an engine sitting here. We have an igniter in it. We put an electric current through the igniter. It gets hot. It ignites the fuel. Fuel burns very quickly. Then the delay charge starts to burn. It burns much slower. Eventually it gets through to the ejection charge and bang, it goes off, pressurizes the rocket, and ejects a parachute. To put all that in summary, there are different phases these engines go through. First, you ignite the engine. It starts the fuel burning. Second, the fuel continues to burn. It burns very rapidly. It provides a lot of thrust. This is what produces the acceleration phase of the rocket. We consume all the fuel when we start into the delay charge. The delay charge burns very slowly. It makes some smoke to help us see the rocket, but it doesn't really produce any thrust. This is occurring during the coasting phase of the rocket. And finally, we get to the end where the ejection charge goes off. It pressurizes the upper part of the rocket, ejects the parachute, and we go into the recovery phase of the flight. This has been Rocketry Basics, Black Powder Engines. After watching this video, you should download and/or print a copy of the Black Powder Engines Summary for future reference.